Hey guys, welcome to this video. In the last video, we introduced some graphical displays. If you haven't watched it, be sure to check it out. Today we are going to talk more in depth about graphs. That is, we are going to interpret graphs today. Last time, we talked about how graphs give us an immediate impression of the patterns and shapes of the data that we are dealing with. To describe graphs, we always comment on four aspects. They are center, spread, outliers, and shapes. First, let's talk about the center. The center is the median value of the data. That is, if you arrange the data by its value from lowest to highest, the center is just the value of the data right in the middle. On the graph, it will separate the values, or the area under the diagram, roughly in half. Here are two examples. On this histogram, the center is 2 paths, because see how it splits the data into two parts that are roughly equal in size? In the case of a stem plot over here, the center is here, 30 students. You can see that the number of data in front of this value is equal to the number of data after this value. Spread is a simple idea. It's the scope of the values from the smallest to the largest. Let's use the same two examples here. To find the spread, we must first find the smallest value, which is 0 path in this case, and then the largest value, which is 4 paths. Then we say the spread of this histogram is from 0 to 4. Similarly, in the stem plot here, we find the smallest value is 9 students, and the largest value is 41 students. Therefore, the spread here is from 9 to 41. Then we have outliers. Just like the name, there are some extreme values that don't really fit into the pattern of the graph. Sometimes they are results of errors made when the data was collected. Other times, outliers could happen naturally because of the variation in the data. Here's an example. We see that the number of push-ups done by most students is around 10 to 20. The trend of the data is that as the number of push-ups done increases, the number of students increases at first and then decreases. But then there's a bump in the tail of the graph. Do we see the number of students increases again because of this bump? No. This one student might be very strong for some reason, but it is not in the trend in which the data is going. So we call this data an outlier. Note that even though there is only one outlier in this graph, there might be several outliers in one graph, and they could occur on both sides of the distribution. Last but not least, let's talk about shapes. There are so many variety of shapes, but here we are only going to focus on the 5 most common ones. A symmetric distribution means that the left side and the right side are mirror image of each other, just like this. A skewed distribution is formed when the data spreads far and thinly towards one side. A graph is skewed to the right if the long tail is pointing to the right. On contrary, if the tail is pointing to the left, then the graph will be skewed to the left. A bell-shaped distribution looks like a bell. It is symmetric, with a tall center and a tail on each side. A distribution is uniform if the data forms a horizontal line. You might have already realized that it is almost impossible to get perfectly symmetric, bell-shaped, or uniform distribution in real life. So we usually say the graph is approximately symmetric, bell-shaped, or uniform. So recapping, today we talked about how to interpret graphs, because graphs have a lot of advantages. We described graphs from 4 aspects, which are center, spread, outliers, and shape. For shape, we focused on the 5 most common ones and talked about each of them. And that's the end of the video. Thank you for watching.